Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the Specialist Maths Exam 1 2016 sample paper. And yeah, let's smash through this paper. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. And yeah, let's start through this video. So okay, question 1. Show that root 5 minus I is a solution of the equation this, or 1 mark. So we're saying that z equals root 5 minus I is a solution to that equation. One way we can show it is, if we can sub it in here, it should equal 0. So that's what we're going to do. We're going to say sub in equation. Let's do that. So it means that will be root 5 minus I to the power of 3 minus root 5 minus I, then z squared, which is just, root 5 minus I to the power squared. And these actually can just be put together. And just put that together and say to the power of 3. Plus, we can take a common factor of, so we can take, so for z, so z is still root 5 minus I, minus 4 root 5 plus 4i. Okay, so these together equal 0, so that's good. And this over here, have a look at this. So that one, root 5 minus I. If you take a common factor of negative 4, it'll be, minus I. And that also equals 0, so hence, you've shown that, when you sub, you've shown that it's a solution. And yeah, that's it. So z is a solution to the equation. That's it. Find all other solutions of the equation this. So, okay, well, I just had a look at it right now and saw that, I think grouping will be the best way to factor this out. So, if I take a factor for this one, z squared, a common factor of z squared out, I'll get z minus root 5 minus I. And if I take a common factor of 4 from here, plus for z minus, and root 5 minus I. Is that right? If I put that there. Yes, and that should equal 0. So we can take a common factor of this out from the equation. So we can say that's z minus root 5 minus I is equal to z squared plus 4. And that should all equal to 0. Now, luckily, this one, we've already calculated the solution. We've already told us that's root 5 minus I. So this is our other solution. So what is z squared plus 4 equals 0? So z squared equals negative 4. Z squared equals plus or negative 2i. So these are your other solutions. And yeah, that's good. So let's do that. Move on to the next question. Question 2. Given the relation this, find the gradient of the normal to the graph of the relation at the point in the first quadrant where x is equal to 1. Let's first find the coordinates. So what I'm going to do is I'm going to sub 1 into this equation and calculate y. So if I sub in 1, so it'll be 3 plus 2y plus y squared is equal to 11. So we can say y squared plus 2y. That's supposed to be 11. If I bring that there, it will be negative 8. Is that right? Yes, equals 0. I'm just going to complete the square. So y squared plus 2y plus 1 minus 1 minus 8 should equal to 0. So that will be y plus 1 squared equals 9. Y plus 1 is equal to plus or negative 3. So therefore y is equal to negative 1 plus or negative 3. Hence we can say that the two values of y is negative 4 and y equals 2. Now if I was drawing these in a quadrant, like have a look at this. If I'm drawing these two y equals, so the point, for example, the point y equals -4 is over here, and 2 is here. Where they tell us that the first quadrant, we want that point is in the first quadrant. So remember, this is the first quadrant. This is your second, this is your third, and this is your fourth. So your first is over here. So it will likely be this one over here, which is y equals 2. So choose y equals 2. So y equals 2 is your point. So this is our coordinate. We can just cross that out. So we can say that the coordinate is 1, 2. Now, what I'm going to do is I'm going to derive this using implicit differentiation. So you should know that, okay, if I'm implicit differentiation this, I'm going to have to ddx everything. So ddx 3x squared plus ddx 2xy plus ddx y squared ddx, oops, not enough space, but ddx, the constant 11. Okay, and let me just make this small. This point over here, we don't need that, so put that over here. All right. So, okay, deriving this point over here, it's very easy. So it'll be 6x squared, so 6x. Okay, now look at this one. We have in terms of x and y, so we're going to use the product rule. So let's go on top here and use the product rule. Let's let u equal 2x and let v equal y. Hence u dash, let's call it u dash, is equal to 2. And v dash is 1, but remember, because it's in terms of y, we always have to multiply by dy dx. So pretty much, it's just dy dx. Hence, we're just going to use the product rule. So the product rule states that these get multiplied, added with these. So just do that. It will be plus 2x dy dx plus 2y. Also, this one, derivative is just plus 2y. Because it's in terms of y, we're going to multiply by dy dx. Is equal to this constant, which is 0. Nice. And what I'm going to do is, okay, I'm actually going to sub these points in there. So when x is 1 and 2 and y is 2. So if I sub in 1 here, plus 2 dy dx, plus 2, which is in terms of 4 here. All right, that's 4. Plus 4 dy dx equals 0. So we can pretty much add those. So that'll be 6 dy dx is equal to -10. Yep, bring those. Yes, so hence your dy dx for this case is -10 over 6, which is -5 over 2. But we want the gradient of the normal. So your m value is -5 over 2. So your m perpendicular is -1 over -5 over 2. Which will be 2. I'm sorry, it's supposed to be 3 here. Why did I mess that up here? So it'd be -5 over 3. This is supposed to be 3 here. And also here it's supposed to be 3. Hence it will be 3 over 5. That is your gradient of the normal to the graph like this. Yeah. So hope that's right. So that's that. And yeah, have I messed anything up? Doesn't look. So let's move on to the next question. Did it find a gradient? Yeah, we just had to find a gradient. Question 3, so let's find it. So a coffee machine dispenses volumes of coffee that are normally distributed with a mean of this. So this is the coffee mean. This is the mean for the coffee. And a standard deviation of 8. The machine also has the option of adding milk to the cup of coffee, where the volume of milk dispensed is also normally distributed with a mean of this, and a standard deviation of 2. Let the random variable x represent the volume of coffee that the machine dispenses, and let the random variable y represent the volume of milk that the machine dispenses. Let x, y be independent random variables. Okay. Find the mean and the variance of the volume of combined drinks. That is the cup of coffee with milk. Okay. So we know that, okay, so a cup of coffee, so you can see, let's actually let's say a cup of coffee is going to have both a X and Y, which is, X is the coffee and Y is the milk. So if we want the mean, so we want the expected value of C, which is the expected value of X plus the expected value of Y, it's going to be, well, we know that the mean for the coffee is 240 plus the mean of the milk is 10, hence it will be 250 milliliters. And if we want the variance, so we want the variance of C, that will be the variance of X plus your variance of Y, which in this case, let me just move these over here. Your variance of the coffee is just the squared of the standard deviation, which is 64, plus the squared of the standard deviation for the milk, which is a 4, which hence it's 68 milliliters. So find the mean and the variance of the volume. That's it. Those are your two answers. Next question. Ooh, let's open the video. Did the paper just disappear? Okay, yeah, we're back. Wow. Okay, so let's finish the question. Wow, guys. I just don't know what happened. So, the thing froze, so let's just finish this video. A second coffee machine also dispenses volumes of coffee that are normally distributed. The owner has been told that the mean volume again is 240. The owner is concerned that the second coffee machine is on average dispensing less than the first one. A sample of 16 cups of coffee with no milk is dispensed that is found to have a mean volume of all coffee served in the sample to be this. Assume that the population standard deviation of still A is unchanged for the coffee. State the appropriate null and alternative hypothesis for the volumes V in this situation. Alright, so okay, the null hypothesis states that there's no change. So your mean is your original, which in this case is 240. And your alternative hypothesis states that there is a change, which in this case we're saying that the mean is less than 240. We're saying that it is 235, which is less. Those are your done. All right. The p-value for this test is given by this expression, probably that z is less or equal to a, where z has a standard normal distribution. Find the value of a, and hence determine whether the null hypothesis should be rejected at the 0.05 level of significance. All right, so we want to calculate this. So your p-value is just this expression right over here. P is equal to the probability of z less or equal to a. And we want to calculate the a value. So we know that a value is what? It is, the a value is going to be, in this case, it's going to be 235. So 235 minus your mean, which in this case is 240, your normal mean, divided by your standard deviation. But this is for the standard deviation of the sample mean. So standard deviation of the sample mean, which in this case is, what is the standard deviation of the coffee? We said it was 8 milliliters, so it's going to be 8 divided by square root of n, which in this case, our n value is 16 cups, so it's 4. Let's put that right over here, 4, which is 2. So your standard deviation is 2, so we can put a 2 over here. So your a value is -5/2. That's it. Which, is equal to -2.5. That's your a value. So it says find the value of a, and hence determine whether the null hypothesis should be rejected at level 5 confidence interval. So, okay, let's think about it. So if I'm saying, if I was drawing a diagram over here, and for the null hypothesis, have a look at this. If I draw this right over here, if I draw a standard normal distribution and say, okay, here, I want to see if the probability of this, so this over here, is it less than 0.0? Because, okay, so let's think about it. Okay, so this is saying the probability that, okay, so we know for a fact, okay, that we know that if this is 0, because this is a normal distribution, we know that -2 here, sorry, 2 here, and -2 here is, we know that this is 0.95, yes? We know that it's around 95% confident here, we're 95%. So here is going to be 0.025, and here also is going to be 0.0025 on those places over here. So this also is 0.025. So if I was, like, for example, calculating the p-value, so the p-value is the probability that z is less or equal to -2.5. So -2.5 is approximately here. So let's say it is, you know, -2 less, but I know it's not the best, but this is how I would do it. So I know -2.5 is approximately there, so I'm still going to take this as an approximate p-value. So if I say that p-value is 0.025, is the p-value less than the level of significance? Yes, it is. So if, in this case, we can see that it's less than 0.05, so we can say that p is less than 0.05, hence we reject the null hypothesis and accept that there has been, so hence we reject the null hypothesis and accept the decrease in coffee dispense, accept the decrease of coffee. There we go. Yep, so done. I hope that's right. So we've just perfect. 2 marks, wow. Question 4. The region of the first quadrant enclosed by the coordinate axis, the graphs of the equation this, and the straight line x equals a, where a is greater than 0, is rotated about the x-axis to form a solid revolution. Express the volume of the solid revolution as a definite integral. Okay, so what I'm going to do here is, okay, let's graph it to see how the graph looks, actually. I'm graphing this. So e to the negative x, it's going to look like this. Well, it's not the most nicest, but it's like this. Done. Let me make it something like that. Nicer so we can see it. And approaches 0, you know. So it says the region in the first quadrant, so this quadrant over here, is enclosed by the coordinate axis. The graph of this and the straight line x equals y, where a is greater than 0. So straight line a is, let's say it's here, where is a equals 0, and the coordinate axis. So we're talking about this one over here. So this over here is going to be rotated around the x-axis. So if it was being rotated, it would look like this. Imagine being rotated around the x-axis. Yeah, so that's okay. At least we got that. That's what we want. So it says express the volume of the solid revolution as a definite integral. Not too bad. So we know that, okay, the volume is pi, because we are, you know, rotating about the x-axis, it's going to be in terms of dx, and hence we're inside here, it's going to be y squared. And these are going to be in terms of x, so it's going to be from 0 to the value of a. Well, what do I want to say? A equals 0, just a. So we're saying from 0 to a, y squared. So this over here, if we square it, it's going to be e negative 2x. E negative 2x. That's it. That's your answer. Nice. That's good. Let's put it right there. Next question, calculate the volume of the solid revolution in terms of A. Okay, so calculating that, so let's integrate this. Volume is going to be pi. Integrate this, so it's going to be 1 over, with that, so negative 2. E negative 2x. Close bracket from 0 to A. It's going to be pi. Negative 1 over 2. E negative 2A. Minus. Alright, and negative 1 over 2 is 0. Close. So pi is just negative e negative 2a over 2. So that's going to be 1 plus half. Alright, let me put that here. It's going to be e to the 0. Alright, so and then just simplifying this, it's going to be your volume. It's going to just be pi on 2 negative e negative 2a plus 1. Is that right? In terms of cubic units cubed. Is that right? So we took the half. Looks good. Okay. Find the exact value of a if the volume is this. So, okay. So we know that if the volume is 5 pi over 18, we just let it equal to pi over 2 negative e negative 2a plus 1. We can cancel those pi's out. We can cancel 9 here. That cancels that out. So we can say 5 over 9 is equal to negative e negative 2a plus 1. So e negative 2a is 1 minus 5 over 9, which is 4 over 9. So it will be e log e of 4 over 9 is equal to negative 2 over a. And we can take this, simplified it by saying 2 log e 2 over 3 is equal to negative 2a. And we can cancel those 2's out, so we get negative log e 2 over 3 equals a, which is just log e 3 over 2 equals to a. Done. So question 5. A flower pot of mass m kilograms is held in equilibrium by 2 light ropes, both which are connected to a ceiling. The first rope makes an angle of 30 degrees to the vertical and has a tension force of T1, so this one over here, T1. The second rope makes an angle of 60 degrees to the vertical and has a tension 2, T2. Show that T2 is equal to T1 over root 3. So what I would do is, okay, I would break these vectors down. I think the most useful is breaking down horizontally because it doesn't involve the value of m, which is the mass. So for example, if I break this, vertically, if I break, resolve them, these two vectors, resolve these, so T1, T2, so if that's 60 here, it means this one over here must be 30. This one over here must be 60 also. So, resolve these vectors, these two vectors over here. These and this one should be equal because they are in equilibrium. And there's no movement of right or left, so that's good. So we can equate them. So that will be T2, which is that one. It's going to be the sine of 30 degrees, which is pi on 6. Is it going to equal to T1? Why did I write a sine, actually? It's supposed to be cosine. So T2, not this one, we want this one over here, which is, cos of pi on 6, which is equal to T1. So that would be sine, so it would be cos T1 cos pi on 3. And so T2 is root 3 over 2. T1 is just a half. So we can say then T2 is, root 3 is T2. The other one's T1. So therefore, hence T2 is T1 over root 3. That's nice. Perfect. That property is true. The rope is strong, but the second rope, the first row is strong, but the second row will break. So the second row, so T2, will break if the tension exceeds 9.8. So if the tension 2 is greater than 98, the pretty much the row breaks. Find the maximum value of M, so the mass, for which the flower pot would remain in equilibrium. So, okay, the most maximum value is when T2 is equal to that 98. Remember what we said? We said if T2 is greater than 98, but not equal. So if T2 is greater than 98, it breaks. But if it's equal, that's the most highest and most maximum equilibrium we can achieve. So, okay, so we're saying that T2 should equal 98, to find that maximum value of newtons. And we know this property over here, luckily, that we can easily calculate T1 just from this. It's just T1 is just 98 root 3. Done. So we got T1 and T2. So resolving this vector over here, remember there is gravity. So it's just mg. It's called mg. That's going to be acting. And okay, now we just have to resolve them now in the j direction, so the vertical direction. So it's going to be T2, which in this case is 98. So T2 will be 98 sine pi on 6 plus T1, which in this case is 98 root 3 is going to be sine pi on 3. And that should equal, because it's still in equilibrium, these two vectors over here should equal to mg over here, which is mass g. Sorry, it is g. So 98 times half plus 98 root 3 is equal to root 3 over 2. Is equal to mass times g. Okay, so this will be 49. Yes. Plus, if these ones, this one over here becomes 49. So what's 49 times 3? So or you can say it as 3 times 49. 349 should equal to here mg. So if we can actually add these two up, we can just add them as 449. Is equal to your mass. And what's g? Well, it's 9.8. So 9.8 can be written as, so 9.8 can be written as 98 over 10. So let's write 98 over 10. And okay, so so this 449 divided by that, it's going to be 10 divided by 48. 98 should equal to a value of m, which we can say this goes twice to this. This goes twice to this. So what's 2 times 10? So m should just equal 20 kilograms. So let's write that down. M is equal to 20 kgs. That's when you get maximum. Nice. That's not too bad. Question 6. Evaluate this integral. Alright, that's not too bad. So, just having a look at this. If I let u equal cos 2x, because I know that when I derive this, it's going to be in terms of sine, so I can multiply that out. So cos 2x. And a lot of students will, maybe if they use sine, it's a problem using a sine because, for example, if you derive it and it will be cos, you can only take one cos out. You need, that's why it's better to take that cos squared as, letting it is u. And therefore, we know that dx is going to be 1 over negative 2 sine 2x du. Is that right? And then, so we can therefore integrate this. Okay, pi over 2. If I sub pi over 2 into this function over here, what is cos pi, which is negative 1? If I sub 3 pi on 2 into cos 2 pi, it will be cos 3 pi on 2, which is 0. We get this. So we can write cos 2x is just u squared multiplied by sine 2x. And luckily now we know what dx is, so we can replace it with this expression. -1 over 2 sine 2x du. And we can just cross those out. We can take that constant out, so we can say it's -1/2. Integral from -1 to 0 e squared du. So -1 over 2 u to the power 3 over 3 from -1 to 0. And that'll be -1 over 2. Divided, that'll be 0 minus -1 over 3, which is -1/2. 1 over 3, which is -1 over 6. That's it. That's what it simplifies to. Done. Question 6. Solve the following differential equation. Nice. So for y, given that when this is your initial condition. So I should already just have a look. It's in terms of x and y, so I'll probably use separation of variables. So dy dx is going to be y times 1 over x squared. So when I use separation of variables, I'm going to integrate. This y over here, I'm going to write it as 1 over y. I'm going to take the reciprocal of it and multiply by dy. And we're going to take the integrate of this one over here, which is 1 over x squared dx. Done. So let's, integrate that. So this one's going to be log e absolute value y is equal to, this one over here, if it's just x -2. So if I add 1, it'll be x -1 divided by -1, which is just -x over -1, which is -1 over x. So this can be just -1 over x plus c, where we have a constant. So that constant, we can solve it by using this initial condition. So we know that when y is equal to -1, which will just become log e1, which is 0, is equal to -1 over 1 plus c. So hence, c is just 1. So let's write that down. So log e absolute value y is equal to -1 over x plus 1. So let's solve for y. So it'll be e -1 over x plus 1 is equal to the absolute value y. Now, absolute value, we can rewrite that as, to get rid of that absolute value, we can plus or negative this e, -1 over x plus 1, and this y becomes normal. So what you can do, if you don't know the absolute value, you just can rewrite it as plus or negative y if you want to get rid of it. So that is what I did over here, but I just brought it over here. Now, okay, we need to check if these conditions are met. For example, we have an initial condition. So if I say that if I let x equals 1, I should pull out an output of -1. Let's check that. So if I put x is equal to 1, so plus or negative, x is equal to 1, which we get -1 plus 1. That'll be 0, which, will become 1. This will become 1 equals y. But it says y is equal to -1, so we should only take the negative. So it means that this over here should only be negative. Hence, your final answer should be y is equal to -1 over x plus 1. Done. Question 8. Write out a definite integral in terms of theta that gives a arc length from 0 of theta to equals 0 and theta equals pi for the curve defined parametrically by this. Nice. So in your formula sheet, you should know that there's a formula for the arc length for parametric equations. It is, in this case, so it will be length is equal from, because we're going from, let's write it actually over here. We're going from 0 to pi, and it is the square root of the dx d theta squared plus dy d theta or squared. So this is your, in terms of d theta. So this is your actual formula for arc length. So let's actually calculate what your dx d theta is. So you need to find the derivative of this. So dx d theta is going to be negative 2 sine 2 theta. And your dy d theta is the 2 cos 2 theta. Is that right? Yes. So putting these expressions all into this equation. So let's do that. So it will be the square root of, okay, so it will be negative 2 sine 2 theta all squared plus 2 cos 2 theta all squared d theta. And so, yeah, it just says write down an indefinite integral in terms of theta that gives the arc length. This is your, equation. That'll be, Well, you can really simplify it more. So, like, let me just simplify it more, actually. This can be written as 4 sine squared theta. Also, this one can be also written as that. Plus 4 cos squared theta. And so, hence, find the length of the curve. Easy. So, using this equation, we know that if we take common factor of 4, we get sine squared theta plus cos squared theta d theta. And this over here, you should know that should equal to 1. So we can rewrite this as 0 to pi is the square root of 4, which is in this case 2 d theta. Hence, integrating this is just going to be 2 theta from pi 0. So therefore, 2 pi minus 0, which is just 2 pi. So your answer would be 2 pi. That's your length. Nice. Easy. So question 9, consider the 3 vectors A, B, and C, where M is an element of all reals. Okay. Find the values of M for which the magnitude of B is 2 square root 3. Easy. So to find the magnitude of B, it's going to be the square root of 1 squared plus 4 plus m squared, and that should all equal to this, which you can simplify as 4 times 3, which is just root 12 in this case. Let's calculate that. So that should equal to 5 plus m squared is equal to 12, which m squared is 12 minus 5, which is 7. So your m is just plus or negative root 7. And here we can have both values, actually. So also find the values of m such that a is perpendicular to b. So if we want a to be perpendicular to b, their dot product must equal 0. So let's do that. So a dot b, so 1 times 1 is just 1, plus negative 1 times 2, which is negative 2. So we can take that out here, right, as negative 2. And 2 times m, which is plus 2m, and that should equal to 0. So 1 is equal to 2m, so hence m is equal to a half. That's it. Calculate 3c minus a. So that's easy. So what's 3? What's our value of c? I plus j minus k minus a. So a, which is just going to be negative I plus j minus 2k. Simplifying this much further, so it'll be 3i plus 3j minus 3k minus I plus j minus 2k, which is 2i plus 4j minus 5k. Hence, that's your actual final. So 3c, actually, 3c minus a is equal to 2i plus 4j minus 5k. That's your final answer. Hence, so it means using this over here, find the value of m such that a, b, and c are linearly dependent. So what is linearly dependent? It means you can create a combination. So for example, having you look at this, 3c minus a creates a combination that creates the other value, which in this case could be, it's supposed to be b. Yeah, but there's also a scalar. For example, it could be, you know, a constant that's 2, 3, and yeah, that's what it means. It means that if you put a combination of these, they equate to one of them. So like a combination of this should equate to this. That's what linearly dependent. It means they are all linearly dependent to each other. So what I would do is, okay, I know for a fact that, okay, there's going to be, it should be equal to b, but there's also going to be some, you know, constant. So I'm going to call that constant alpha in this case. So we know that, you know, 3c minus alpha a, this vector, is this. So it's just 2i plus 4j minus 5k. And that should equal to alpha times the b vector, which is bi plus 2g plus, oh, wait. What am I doing actually? What am I writing b? I'm supposed to write alpha I plus 2 alpha j plus alpha mk. All right, so what do we see? Well, have a look at this. If you're looking at this over here, look at the difference. Can you see this 2 over here? Can't you see it equates with the alpha over here, as you can see? What about this one over here? 4, isn't it? If alpha is 2, it's going to be 4j. So if alpha is 2, this is 2i. So it's likely, so therefore alpha is actually, in our case, alpha is 2. So, okay, that's very good. It means that if alpha, in this case, is 2, for this one over here, -5, if alpha is 2, it'll be 2m. So what we're saying is this expression here. So if alpha here is 2, we write, so, and it should equal to, so 2m should equal to that -5 over here. So therefore, your m value is -5/2. That's it. So yeah, that's using our linear dependence. Look, you can usually normal use the normal if you want to solve it, you know, but it's only 1 mark. So understanding what linearly dependent is using this expression, yeah, that's what they're trying to test you over here. But for example, you can also use, you know, do it by the long method, which, you know, find a linear combination, blah, 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 all that. But yeah, for this question, it's only 1 mark. Question 10, is this the last question? Yes. Verify that 5x to the power 3, that can be written as this. So we want to write it in partial fraction. So we need to look at the actual, what do you call it? The denominators. Can you see how this one's x squared? So we can rewrite it as, we're going to have alpha over x squared. But we're also going to have b, it's also going to be x. Plus, what about this one over here? It's going to be, you know, x squared plus 4, but it's logically not squared. And because it has the x squared as the highest polynomial in it, it's going to have 2. So it's going to have, so cx plus d. So it's going to have 2 things that we don't know. And luckily, if you're too confused, you can actually have a look over here. They've kind of given you how it should look. So, you know, x squared should have 1 variable. This one has 1 constant, and these should have 2 constants. Yeah, but you should know how to do those. You should know how to decompose them. And yeah, so that over here should equate to the 1 over x squared. I mean, not that, but it should equate to 5x to the power 3 plus 12x plus 4 all over x squared plus 4. Now, if I multiply everything here by x squared times x plus 4, so that's multiplied by, you know, a, b, plus, again, x squared plus 4 times by bx plus x squared plus 4 multiplied by cx plus d over x squared plus 4. We can kind of simplify it because, have a look at this. Why did I write this like that? So it's supposed to be x squared. So we can cancel these out. So it will just be alpha. So a is equal to x squared plus 4. Whereas this one over here, if I can cancel this out and get one of these, so it'll be plus b x is x squared plus 4. Plus, I can cancel that and that, so it'll be x squared times cx plus d. So just a little bit simplifying that, we get this beautiful expression over here. And this expression should equate, this whole expression should all equate to the top of this part over here. So 5x to the power 3 plus 12x plus 4. So let's kind of simplify. So ax squared plus 4a plus bx cubed plus 4bx plus oh god, that's a c, so I don't want to forget that. So it'll be plus cx cubed plus dx squared should equal 5x3 plus 12x plus 4. By equity, equality, I call it, but equity, I think so. It's, yeah, they should, you should equate them. For example, the terms of the x to the power of 3, where are they? It's this one over here and this one. So we're saying b plus c should equate to 5. Okay, what else can we do? Now look at x squared. Well, here there's no x squared, so it means 0. But so here we have x squared, so it'll be this. It'll be a. What else is x squared plus d is actually equal to 0. What about the linear one? So 1 to the power 1. We have 4b. Yeah, just 4b is equal to 12. And the ones without variable x is just going to be 4a. That's it. 4a is equal to 4. So therefore, we already know we can, a is just 1. Let's put it here. So a is equal to 1. B is just 3. Now we know a, so we can put a in here. So it will be, d is therefore -1. And luckily we know b, so it's just going to be c is just 2. Yeah, so we know a, b, and d, and c. And yeah, so put them inside here. Like, oh my god, it's a lot of working out. I know, for this kind of question, putting that little working out, it's quite crazy. So, let's put, so the a we know is what now? 1. B is 3. Now c is 2x, so it'll be 2x, and d is -1. See, they are the same, so we've just proven it. That's it. Sorry guys, my video just stopped. Yeah, so it says find an antiderivative for 5x to the power 3 plus this. Okay, luckily we know the expressions over here, so we can just easily use that expression to integrate that this one. So we can just rewrite this as x to the -2. This one over here, we'll leave it as 3 over x. This one over here, we can actually split it, so we can write it as 2x over x squared plus 4. X squared plus 4 minus 1 over x squared plus 4 dx. So integrating this one over here, it's very nice. So it's just x -1 over -1. This one over here is just 3 log e. absolute value of x. What about this one over here? We just have to use substitution. So if we let u equal x squared plus 4, therefore dx is going to be 1 over 2x du, which hence, rewriting this, it will be 2x u multiplied by 1 over 2x du, which, we can cross those out. It's just 1 over u. So integrate of that is just log e absolute value u. And we know that u is x squared plus 4. So let's write that down. So plus log e absolute value x squared plus 4. All right. So we simplify that one here. Now, okay, x squared plus 4. So we know that if we shove any number into x squared, it's going to be a positive. And we're also, adding over a positive, we don't actually need those absolute values. Hence, it's always going to be a, greater than 0. So we can rewrite this as x squared plus 4. And this one over here is an inverse of tan. So let's have a look at it. Let's put a minus here. So to integrate this, x squared plus 4, we're going to need a 2 over here. Because the square root of 4, there needs to be a 2 here. So if I'm going to put a 2 here, I'm also going to multiply by half because I need to cancel that 2. Remember? Because it needs to be 1 only. But so yeah. So I know this one over here, hence it's just going to be half times your tan inverse x over 2. Beautiful. So let's write that down. Minus half tan inverse of x over 2 plus c. Done. Nice. And we are nearly done. Let me just actually close that bracket and then plus c. Now, because it says find antiderivative, we can just let c equals 0 in this case. So, a little bit simplifying this whole thing. So, this is just negative 1 over x plus 3 log e absolute value x plus log e x squared plus 4. Well, you can add these, but I mean, that's very important anyway. So yeah, so add those. Negative 1 over 2, tangent inverse of x over 2. And yeah, that'll be it. Pretty much that's the final answer. So thank you guys for pretty much watching this video. I hope you guys really enjoyed this video. And if you guys, have any friends or teachers, you can always, make sure, tell them about my channel. It'll be a great pleasure. I just want to say thank you to all who are watching my videos. You guys make me very happy. And yeah, I hope in these holidays I should be, smashing out all these special content videos. And yeah, if you guys, again, want any special, tutoring, you can always email me through that email. And yeah, guys, take care of yourself. Have a good day. Bye-bye.